Hi kiddos, welcome back to another round of Ms. Lambert's mini lectures. So, in this mini lecture, I'm going to talk to you about calculating molar mass. So first things first, what actually is molar mass? It is the mass of 1 mole of a substance. It tells you exactly what it is inside of here. So what is a mole? A mole is defined as 6.02 times 10 to the 23rd particles. So this is a number that you should have memorized. 6.02 times 10 to the 23rd, an insanely large number. But remember, we're working with things like atoms or ions or compounds that are just tiny, 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 so little. So we are talking about large quantities of these things on a macroscopic scale. It's actually an insane amount of particles that have all piled up. So working with a number this large, this counting unit for a chemist makes a lot of sense. So what could particles be? Particles, we could be talking about atoms, we could be talking about ions, we could be talking about molecules, we could be talking about formula units, etc. There's lots of other things we could be talking about. A particle is just an umbrella term. So molar mass can be calculated for any compound. You don't really have to do much calculating if it's an element. If you wanted to find the molar mass for any element, all you have to do is consult the periodic table. I'm just going to shorten it to P table. What if it's diatomic? So what if it's on our Hofbrinkel list? Remember, those elements only exist in the natural world bonded in those pairs in their elemental form. So if it's diatomic, then you do have to do a very quick calculation. If it's diatomic, you consult the P table and double it. Double the mass on the periodic table. So let's do a quick couple of examples. So here's some element tabs that I've pulled from ptable.com. These are elements neon on the left, nitrogen on the right. So quick review of the structure of these element tabs that we've seen before. This number that you're taking a look up at the top, this is your atomic number, represented by the letter capital Z. Atomic number represents number of protons. It gives the element its identity. So neon has 10 protons in it. Then you've got its element symbol, Ne, its name, neon, and at the very bottom, there's this number right here. So this is referred to as the average atomic mass, or affectionately known also as molar mass. So this number at the bottom, the reason why it's written as a decimal is because it takes into account the masses of all isotopes of this element. And then based on their abundances, it says the average value, the average mass of a neon atom is approximately 20.180. If you were to pull any neon atom, its approximate mass would be 20.180. Remember that the actual mass number of an atom is always whole, because for that one, you're adding up number of protons and number of neutrons, and you can't have a part of a proton or a part of a neutron. So this number here as a decimal is taking into account the mass of every isotope of this element. So neon, is that on our Hofbrinkel list? Hofbrinkel, spell it out to yourself. No, neon's not on there. So what this is saying is this number at the bottom is the molar mass for 1 mole of neon atoms. So 20.180 grams per mole. This is the molar mass. What this is saying is that there are 20.180 grams per 1 mole of neon atoms. And remember, just to hammer that home, 1 mole of neon atoms is 6.02 times 10 to the 23rd neon atoms. So the other way you could write this ratio is you could say, oops, let me move this back up here. For 6.02 times 10 to the 23rd neon atoms, that would weigh 20.180 grams. Just another way of writing this. So hammering it home, this is the molar mass. So what about if you had something like nitrogen? So its atomic number is 7. 7 protons in nitrogen. And now you have this average atomic mass, 14.007. Is nitrogen on our Hofbrinkel list? There it is, nitrogen. So nitrogen's on the Hofbrinkel list. This is a diatomic. If you wanted to find the molar mass of elemental nitrogen, the formula for elemental nitrogen is N2. So if you want to find the molar mass for nitrogen, you gotta double it. So if I take 14.007 and I double it, I should get, well, let's see if I can do this math in my head, 28.014 grams per mole. So again, this is 28.014 grams per 1 mole of N2 molecules. So remember, if you have 2 atoms that are bonded together, you have made a molecule, or sometimes you have made a compound. We'll talk about, you've always made a compound, but we'll talk about the difference again coming up in our next unit. But here, the molar mass for elemental nitrogen would be 28.014 grams per 1 mole. So now let's say you got something a little bit more complicated. Now we're going to do an example, or 2 examples with compound. So your first example is sodium chloride, NaCl. So here's the deal. Honestly, if you have a periodic table handy, a calculator, and you remember how to count atoms, this exercise should be fairly easy for you. If you can count atoms, all you got to do is add on 1 extra step now and figure out their molar masses from the periodic table for each of the elements that are present in this compound. So if we take a look at sodium chloride, you've got 2 elements here. You got sodium and you got chlorine. How many of each do we have? So for sodium, I see no subscript to the bottom right-hand corner, which means I must have 1 sodium atom. What about for chlorine? Again, no number is shown. I must have 1 of those. If I want to now figure out the molar mass for this compound, I have to take the molar mass for each of the individual elements that are present. So for sodium and chlorine, you're going to look them up on the periodic table. So let me pull up periodic table here. Sodium's right here, 22.990. Ooh, come on, iPad, stop freaking out. 22.990, and chlorine's right here, 35.45. So I'm going to head back and write those in. So 22.990 grams for 1 mole of sodium atoms, and I have to factor in the 35.45 grams for a chlorine atom. And I only have 1 of each of these atoms present, so I just know I don't have to do any extra multiplication for this step here. And now my last step is to add these things together to account for the masses of each of the types of atoms that I have present. So 22.99 plus 35.45, and that gives you 58.44 grams per mole. Don't forget to put your units on things. Units are incredibly important. You got to tell people what you're talking about here. So since we're talking about molar mass, again, it tells you molar mass is grams per mole. The mass per 1 mole of an atom. 1 mole of a substance. Okay, so there's an easy example. 1-to-1 ratio, pretty simple, not any extra multiplication. Now let's do another one. This time you got magnesium nitrate. Okay, again, if you remember how to count atoms, you can do this. So let's start out with the number of elements that I see present in this compound. I've got 1 here, magnesium, got another one here, nitrogen, and another one right here, oxygen. Okay, so let's start by counting our atoms. Mg, how many of these things do I have? Just 1. All right, nitrogen, how many of those do I have? Well, I've got 1 inside the parentheses, but I have that subscript 2 outside. So remember, this factors into each of the elements inside the parentheses. So total, I would have 2 nitrogen atoms. All right, and then oxygens, I've got 3 inside the parentheses. Multiply that by 2, and I've got 6 total oxygens. All right, now I got to figure out molar masses for these things. So take a second, try to do this part on your own. Consult the periodic table, and then come on back and see if you gathered the right numbers. All right, so for magnesium, you should have found 24.305, nitrogen, 14.007, oxygen, 15.999. So these are the numbers that I am using based on the periodic table that I have. You may be looking at a periodic table that rounds these molar masses a little bit differently. That's okay. Whichever periodic table you have, go ahead and use that one. When we're in class, you'll all be pretty much using the same periodic table, so you should be on the same rounding pattern as me. But some periodic tables just go to a few more decimals to get a little bit more accuracy in there. Okay, so these are my molar masses for each of the individual atoms, and I got to multiply it by the number of atoms I have in this compound. So for magnesium, that's not going to change, 24.305, awesome. So for nitrogen, we got 28.014. Oh, yes, my math from up above was correct. I love doing math in your head. Wow. And then lastly, oxygen, 15.999 times 6, and we get 95.994. So now I got to add them all together. Last step, putting this in my calculator. See if you can beat me. All right, I got 148.313, but I'm not done yet because I didn't put my units, grams per mole. There we go. Now we have a correct answer. All right, so there we go. That is how you calculate molar mass. Go ahead and do the practice problems to get some extra practice in there.